Hello, today we will review factorization of polynomial expressions. So the very first example that we do is that of a quadratic polynomial. So you can call this as quadratic polynomial because it has x with a power of 2. So in such case, when we do this problem, we need to find two factors for 30 that would give me negative 11 when I combine them. So negative 5 and negative 6 makes and does that. So x squared, I can rewrite this as negative 5x, negative 6x, and then negative and multiplied gives me positive 30. Now I do what is called factor by grouping. So I pick x as a common factor here and then 6 as a common factor here. So I see that x, I have the same factor x negative 5 in both cases. So I end up combining x negative 6 and x negative 5. So this is how we change this quadratic polynomial into factored form. Now, this was just a quick review from your last lesson. So just to make sure that you recall this thing. Now, a quick overview of polynomial identities. These identities help us solve polynomial problems rather fast instead of going through the tedious process. So it's just a matter of how you identify your algebraic expressions and how smartly you can apply any of these identities in your particular case. So if you notice these first two, we have this square term outside, and we have some two variables x and y, or we can call these as two terms. So in this case, this polynomial is simply called, and this identity is called square of a polynomial. Okay, so whenever you have such a case, you can rewrite it as the square of the first term plus the square of the second term, and then depending on if you have a positive sign or the negative sign in between, you will have plus 2 times the first term and the second term, or negative 2 times first term and the second term. So you can go the other way around as well. If you see a situation where you have two terms in squared form and then you have plus or negative 2 times the first term and the second term, you can rewrite it as first term plus second term, entire thing squared. Okay, the next identity is here. Now here you see I have a square term and another square term, and there is a negative sign in between. So this is simply called difference of squares identity. So whenever you see a situation where you have two terms which are squares of something, and there's a negative sign in between, you can rewrite them as the sum and the difference of the terms, x plus y times x negative. And the same way, you can, if you see something like this, you can rewrite that as square of the first term, negative square of the second term. So these are few common identities. And then if we look down here, this and this, these two are important. You see the cube here and also the cube here. Here you have the positive sign, here you have the negative sign. So this is called sum of cubes identity, and this is called difference of cubes identity. So many times when you are doing the factorization, you may come across situations or algebraic expressions just like one of these, and you can apply these identities right away and simplify. So out of all these, the ones which are more frequently used are square of a polynomial, difference of squares, sum of cubes, and difference of cubes identities. Now, when you are doing factorization of polynomials, you can adopt one of the several strategies depending on the problem at hand. So the most simple form is factor by grouping, and you saw that this is an example where we divided the entire polynomial into smaller groups, and then we factored, and then we simplified. Uh, Another way of factoring is through application of this formula, sum of cubes or difference of cubes or difference of squares. So using any of these polynomial identities, you can as well graph an expression. If you have a polynomial of higher degree, 3 or 4 or even more, and you cannot directly see how you can change that into a factor form, you can just graph it. And once you see the graph, you can identify zeros. Identify zeros are the values of x for which your function is 0. Okay, those values you can use to write down the factors. We'll do some practice with these. And of course, you can do the long division method if you know at least one factor. So let's move on. And here in this table, you can see that we have few examples. Mostly all of these are quadratic polynomials. But in the first case, we see 4 and 6. 2 is the common factor in these numbers. And between x squared and x, we can have x as a common factor. So we just write 2x outside and then rewrite each term after division by 2x. So 4x squared upon 2x is 2x, that goes inside. And then 6x divided by 2x is again 3. So 2x times 2x plus 3 is what you get. Now, if you should always, in your mind, multiply to see if you are getting the same thing. So 2x times 2x is 4x squared, and 2x times 3 is plus 6x. So that's correct. The second one is x squared negative 25. You see x squared is the square of x. 25 is the square of 5. So you can rewrite this as x plus 5 times x negative 5. And the polynomial identity you use is the difference of two squares. Similarly, this is a quadratic problem we did similar to the one. You just have a number 12. You find two factors that would multiply to give you plus 12 and combine to give you plus 7. So 3 and 4 can do that. 3 times 4 is 12. So you can rewrite this as x plus 3 and times x plus 4. Sometimes you may have some number here with before x squared, not just 1 like you had here. In that case, you multiply this number with this number. So then, and you do the same like you did earlier. So negative 3 times 6 is negative 18. And in this case, you find the two factors for negative 18, not just negative 3. And if you do that, and again, those factors should combine to give you plus 7x. So we notice that 9 and negative 2 just do that. So 9 times 2 is negative 18. 9 negative 2 is plus 7. So you just rewrite it as 3x, 6x squared plus 9x negative 2x, and then you factor by grouping, and you get your answer. Now let's do the first example. And you can see that we have 8x cubed negative 27. And I have given a clue that you can use the difference of cubes identity. So 8 is basically 2 power 3. X cubed is 2x power 3. So I can first rewrite both of these terms in cube form. So 2x cubed negative 3 cubed. Then I will simply write 2x negative 3. And then I'll take the square of the first term, 4x squared, square of the second term plus 9. And then if there is negative, I will have positive here. And then the first term times the second term. So 3 times 2x is 6x. So now it's just in 2 steps, I was able to change this into factored form using the difference of cubes identity. Another example. Now I have 4 terms, and apparently nothing is common among all these. So what I do is I see if I can group them, and that may help. So I make 2 groups of these. In the first group, I see that x squared is common. So I write x squared outside, and then inside I will have 2x negative 5. And in the second group, I see that 3 is common. So I will write that as 3 times 2x negative 5. So now I have the same factor 2x negative 5 multiplied with x squared and also multiplying with 3. So this is a distributive property. I can write x squared plus 3 times 2x negative 5. So again, I have changed this to the factored form. So in this method, I do factoring by grouping. And in the first case, I used difference of cubes identity. Okay. Now let's move on to the next problem. And here we just get the help from the graph of the function. So x4 negative 2x cubed negative 7x squared plus 8x plus 12. First of all, we must know what is the degree of this polynomial. So degree of polynomial is the maximum power of x in the function. In this case, it is 4. So the degree of polynomial is 4. Next, when we graph it, we look at the points where the function will cross the x-axis. Okay. So when we do that, we notice that we have x as negative 2, x as negative 1, x as 2, and x as 3. So these are the points, these are the values of x that when I insert into my function, into my polynomial, I will get a 0 output. So f of x will be 0. So now to check if it's correct, let's go with negative 1. F of negative 1 is going to be negative 1 power 4, negative 2 times negative 1 power 3, negative 7 times negative 1 squared, plus 8 times negative 1, plus 12. Okay, so now negative 1 power 4 is 1, negative 1 power 3 is negative 1, negative negative positive, plus 2, negative 1 squared is plus 1, 1 times negative 7 is negative 7, negative 8, and plus 12. So 12 plus 2 plus 1 is 15, and 7, negative 7, negative 18 also 15, so it is equal to 0. So what we do is, in this case, when we have x is equal to negative 2, we take this 2 to the other side. So we have x plus 2. Okay, and same way we have x plus 1. We can have x negative 2 and x negative 3. So this is one factor, this is the second factor, this is the third factor, and this is the fourth factor. So I can rewrite this function as x negative 2 times x negative 3 times x plus 1 times x plus 2. So you can see that using the graphical form of the polynomial, I was able to write down the same polynomial in factored form. Okay. Now we'll have some practice with some problems that have multiple choice questions. There are several options to pick from, and I will tell you different ways to do that. Okay. So let's say you have this polynomial expression x4 plus 2x cubed negative 3x squared negative 8x negative 4. Again, what is the degree of this polynomial? 4. Okay, because x has an exponent of maximum exponent of 4. Then we need to see which one would be the representation of the same polynomial function but in linear factor form. So first of all, the one thing that we quickly do is check if all the terms would give us x power 4. So in this case, we have x, x, x. So when we multiply x with x and with x, we simply have x power 3, not x power 4. So there are 3 factors, linear factors. So I cannot get x power 4 from the first function. Let's do the same with the second. This is in squared form, so you will have x squared, and then this also will be x squared, so that yes is x4. Also this one will be x4 and this will be x4. So based on the first term, I cross out the first option. Next, I try to check for the last term, which is negative 4. Okay, and for that, I simply multiply these numbers. Plus 2, negative 2, plus 1. Well, in this case, this option has already been ruled out, so I'll simply cross it and I will not consider this anymore. Now, going to the second one, negative 2 squared times plus 1 squared. Okay, so negative 2 squared is 4, plus 4, and then plus 1 is plus 4, so you get plus 4. But we need to have negative 4 here, so we need to cross this option out as well. Then let's check with the third one. Plus 2 times negative 2 times plus 1, because square of 1 is plus 1, so plus 2 times negative 2 and plus 1 squared, so that will give me negative 4. Okay, let's keep this option and go to the next one. So now plus 2 times negative 2 times plus 1 times negative 1. So I have two negative signs multiplying, that is will be positive. So I again have plus 4. So this option is also not possible. So all I am left with is h. So you can see that I didn't have to do all the factorization. I just simply eliminated the wrong answers and I narrowed down to the one that is exactly the right answer. Okay. Let's do this example now. Now it says that polynomial of degree 3. So we see yes, it is 3. And then there are 4 choices. Again, we do the same thing. The first term, x times x times x. We have 3 factors. So in this case, all of these will multiply to give us x power 3. Okay. Now, the interesting thing is we have one factor which may be x plus 5 or x negative 5. So let's say we have x plus 5. If we take it as 0, that means x is negative 5. Okay, so what we do is we check if f of negative 5 is 0, because if it is, that means yes, it is one of the factors for this polynomial. So we just insert this negative 5, we replace x with this negative 5 power 3 plus 3 times negative 5 squared, negative 21 times negative 5, negative 55. So 5 times 5 times 5 is 125. We have negative 125. negative 5 squared is plus 25 times 3 is plus 75. Negative 21 times negative 5 is plus 105. And then we have negative 55. So when we add them, we have 150 and we have negative 150. So that is equal to 0. So yes, that is one of the factors. Let's do the same with x negative 5, just to make sure. So if x negative 5 is equal to 0, then x is equal to 5. We'll do the same thing, but instead of negative 5, we will use plus 5. So that is 125 plus 75, negative 105, negative 55. So now we have 180, negative 160. That is not equal to 0. So we say that x negative 5 is not one of the factors. Once we get to this conclusion, we simply cross the terms having x negative 5. That makes our job much easier. Now instead of 4, we need to pick from 2 choices. So very interestingly, when I look at these 2 factors, here as well as here, I see the same term here and the same term here, and I have a different term here, but the same different term here, and there's a negative sign and there's a positive sign. Does it ring some bells? If I take this term as A and this term as B, I have the same form A negative B times A positive B. And that is equal to A squared negative B squared, the difference of squares identity. Okay, so what I do is I just pick option F first, and I say, okay, so I will have x negative 1 squared, the first term, negative 2 square root of 3 squares. That means if I open it up, x squared negative 2x plus 1, and then 2 squared is 4, square root 3 squared is 3, so 4 times 3 is 12, so negative 12. So I have x squared negative 2x negative 11. Okay, let's go and do the h part as well. So the same way, we will have x negative 1 squared negative 4 square root of 3 squared. So that will be x squared negative 2x plus 1 negative 4 squared is 16, square root of 3 squared is 3, 16 times 3 is 48. So now I will have x squared negative 2x negative 47. Now if you look at this term, so this one, and you look at this term, and we don't need to go ahead and do the complete multiplication with x plus 5, but let's look at the 2 numbers. So negative 11 times plus 5 is negative 55. So eat this negative 55. Here, negative 47 times negative, positive 5 is negative 35 and 235. So that is not possible. That is correct. So I say that no, H is not an option. F is my correct answer. So now look at this and just think about the steps we took to get to our final answer. We had the polynomial with degree 3. We had the 4 given choices. And first of all, we checked for x power 3. All 4 were fine. And before we could do the negative 55, we just wanted to confirm which one is correct. So we took both of these one by one and checked which one would give us the output of this function as 0. So from there, we figured x plus 5 is right. So we had 2 options, and then we went on. By the way, this is a bit longer way, but if we go by the same philosophy of getting negative 55, then we can try this. I haven't tried this, but let's do it as a different way. So now, once we knew that x cubed, all of these give the x cubed, negative 55. So in the first case, we have plus 5 times negative 2 square root of 3 times plus 2 square root of 3. So negative, in the end, you will have a negative sign. 2 times 2 is 4. 4 times 5 is 20. And then square root of 3. So 4, 12, 60. So you will get 60 here. Okay. So negative 60. In the second case, you will have negative 5. And then negative 2 square root of 3. And you will have positive 2 square root of 3. So now you will have plus 60. Okay. The thing is, we're not getting 55 because we have this 1 here inside. So definitely we need to multiply that 1 with 5 also. So anyway, the thing is, in this case, if you go by this route, you can eliminate a choice like this based on the fact that you get a positive 50 and you have a negative 55 here. But then you still have this plus 1 that you would need to multiply to get a number. So I think this is a better way of doing this problem. So now let's go to the next example. And we again have a polynomial of degree 3. And we need to find the right set of factors. So here, again, 2x cubed, 2x times x squared, 2x times x squared, all of these would give us 2x cubed, negative 3. Plus 1 times plus 3 is 3 plus 3. Negative 1 times plus 3 is negative 3. Negative 1 times negative 3 will again give me plus 3. And then plus 1 times negative 3 will give me negative 3. I need negative 3, so I can cross out the ones giving me positive 3. So this cancels out and this cancels out. Now I have two choices to pick one from. So what I do is, now I check with this as well as this. Let's check with 3x squared. Okay. So what I'll do, I will not do the complete multiplication because it will take much longer, and I may make the more extensive the problem is, the more chances there are that we may make a mistake. So here we get x squared when we multiply this negative 1 with x squared, and we multiply this 2x with 2x. So 2x times 2x negative 1 times x squared. So it's going to be 4x squared negative x squared. Let me just isolate this one. This is not part of this problem. So this is 3x squared plus 3x squared. Okay, we do need plus 3x squared. Okay, let's do with this with the last one. 2x times negative 2x plus 1 times x squared is going to be negative 4x squared plus x squared. Plus x squared means plus 1x squared. So negative 4 plus 1 is negative 3x squared. So now you can see the difference. This will give me plus 3x squared. This gives me negative 3x squared, which is not what I want. So my correct answer is G. Make sense? All right, so moving on. All right, this is a very different and interesting problem. Which of the following factors produce the following polynomial expression, x cubed plus 5x squared plus 4x negative 4? Once again, whether we use it or not, but we just write it, the degree of this polynomial is 3. Now, don't get confused when you have two sets of options. Basically, these are the 4 factors they have listed and said that some of these, or maybe all of these, could multiply to give you the same polynomial in standard form here. Now, if you see x power 3 and you say that the degree is 3, anytime you multiply, you should be getting x power 3 as your biggest term. So you cannot multiply really all of these. X squared, x, x will give you x power 6. So you need to pick the ones which would multiply to give you this expression. Okay. So first of all, when we say x plus 2 may be one of the options, let's take this as x plus 2 equals 0. So x is equal to negative 2. Do we have f of negative 2 as 0? Let's check. Negative 2 power 3 plus 5 times negative 2 squared plus 4 times negative 2, negative 4. That is negative 8. It becomes plus 4 times 5 is 20. Negative 8, negative 4. Negative 8, negative 8, negative 4 is negative 20 plus 20, that is 0. So yes, this is one of the factors. We do the same with x negative 2 equals 0. That means we just plug x as 2. So again, we check f of 2 is 2 power 3 plus 5, 2 squared plus 4 times 2, negative 4. So now you have 8, which is positive, plus 20. 4 times 5 is 20. Again, positive, plus 8, negative 4. And that is not equal to 0. So we say that x negative 2 cannot be a factor. X plus 2 will be a factor. Okay, so now we need to have one of these. But before we multiply and go on further, we notice that one is here and here. So since one is not here and here, we just cross them out. And then 1 and 2. 1 and 2 means x times x is x squared. We need x cubed. So 1 and 2 also cancel out. So automatically we move on to the option H. Okay. So that is how we solve this problem. So in the end, when I summarize really quickly, I will say you can factor by grouping, or you can factor using polynomial identities. Okay. You can factor by graphing the function. You can also eliminate incorrect choices. And you saw how we use that. Okay. So with that, I will stop here. You do have the independent practice. There are quite a few problems. So every problem, you can use one of those techniques and then pick the right answer or eliminate the wrong answers. By the way, if you still do not get the exact answer, but somehow you can eliminate some choices, that means if you had a chance of 1 in 4 to pick the right answer and you ended up with crossing out the 2 wrong choices, you have a chance of picking the right answer as 1 in 2. So 50% versus 25% is a big difference. So please go ahead and start working on the independent practice problems. And thank you so much.